Okay, this unit is properties of logarithms. There are basically three properties of logarithms that we're going to work with. First of all, you have to know that the m and n we are discussing in these properties are positive numbers, and b cannot be 1. So first property is product property. Okay, in this case, if we have log base b of m times n, in logarithms, it can be rewritten as log base bm plus log base bn. Hopefully at the end, hopefully you guys already knew this from the end of the 8.3 homework. It was kind of a discovery lesson part for you. Quotient property then. So here it's log base bm divided by n. And when there is division within a logarithm, it can be rewritten as log base bm minus log base bn. So that's your quotient property. And then finally, your power property is when you have log base bm to the n power. That power can be moved to the front of the logarithm and it be rewritten as n log base bm. Okay, so those are the three properties we are going to be using and become acquainted with throughout this lesson. Okay, using our properties, we are going to evaluate each expression, so a logarithmic expression. So here, instead of actually evaluating each specific logarithm, we're going to use the properties, write it as a single logarithm, and then evaluate that single logarithm. Okay, so we have log 8 plus log 5 minus 2 log 2. Okay, we know the base of each of those logarithms is 10. So using our properties, when there is addition amongst two logarithms, that is the product property, so we need to multiply. So that's where in red log 40 comes from, because 8 times 5 is 40. And then I have minus log 4, and that came from the minus 2 log 2. I used our power property, and I took that 2 in the front of log 2 and moved it to the exponent. So we have log 2 squared. 2 squared is 4. So that gave us log 40 minus log 4. And now we can use the quotient property. And it would be log 40 divided by 4. 40 divided by 4 is 10. So that log 8 plus log 5 minus 2 log 2 simplifies to log 10. And now that log 10 we can evaluate, because 10 to what power equals 10? And it's 1. So that entire expression simplifies down to just a simple 1. So we can do that again. Let's look at the second problem there in black. Log base 2 of 48, and that's minus 1/3. Log base 2 of 27. Okay, well, we can use the power property and move that 1/3 to the exponent of 27. 27 to the 1/3 power is the same as the cube root of 27, which is 3. So now we have log base 2 of 48 minus log base 2 of 3. Use our quotient property. 48 divided by 3 is 16. Log base 2 of 16. 2 to what power equals 16? And it's 4. So log base 2 48 minus 1/3 log base 2 27 simplifies to 4. Okay, so now we're going to write each logarithmic expression as a single logarithm. So now we're not going to evaluate them, but we're still going to write it down to a single logarithm. Okay, so in this first one, we have 1/2 parentheses log base bm plus 3 log base bn minus log base bp. Okay, so what that means is that 1/2 goes to all three of those terms. So basically, everything in the logarithm is going to be square rooted, because that 1/2 is going to all of it, and 1/2 power, if they're all being raised to the 1/2 power, that means we're square rooting all three of them. So let's simplify what's inside the square root first. So we have log base bm plus 3 log base bn. So that can be rewritten as log base bm times n to the 3rd. Okay, and then we have minus log base bp. So now we can use the quotient property, and we can have log base bm n to the 3rd divided by p. So now it's basically like we have m n to the 3rd divided by p, all raised to the 1/2 power, which means they're all underneath a square root. So in red there, you can see it's log base b. I just couldn't put the square root symbol in, but it's log base b square root of mn to the 3rd divided by p. All of that, what's in the parentheses there, is underneath your square root symbol. Okay, so let's look at a little more simple example, and this bottom one. We have log a plus 2 log b minus 3 log c. to write that as a single logarithmic expression, we can again use our power property, and we'll have log a plus log b to the second power minus log c to the third power. We can use our product property and rewrite that as log a times b to the second power. And then we still have minus log c to the third, so use the quotient property and divide, leaving us with log ab to the second power divided by c to the third. Okay, we're also going to have to expand the logarithms. So here we're given it as a single log, so let's expand it and write it as multiple logarithms. So we have log mn to the second power. We can use the power property, bring that 2 down in front, and notice it goes to both the m and the n. So I have 2 parentheses log m plus log n, because again that 2 goes to both of them. So now I'm going to distribute the 2 to both, and we have 2 log m plus 2 log n. There it is, expanded form. Let's look at the bottom one. This is kind of a special case. So we have log base 3 of 7 times 2x minus 3 to the second. So there's a couple different things going on here. First, we have the product property. So let's rewrite that as log base 3 7 plus log base 3 2x minus 3 to the second power. Okay, now we can use the power property and bring that 2 down, which if you look in red, that's where I have log base 3 7 plus 2 log base 3 2x minus 3. Now notice that 2x minus 3 I'm not splitting up. I'm not changing it to division because it's not 2x minus log base 3 of negative 3. It's that 2x minus 3 is our y value. We can't split that up. That's the group. Okay, so it's going to stay like that. So our final answer in this case is going to be log base 3 7 plus 2 log base 3 2x minus 3. There's nothing else I can do to expand that out any further. Make sure you write down any questions that you have, and I encourage you to ask them in class tomorrow. Thank you and have a great evening.